So the question number 7 is saying a steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces each of magnitude 5 Newton. So this is the wheel whose diameter is given 0.5 meter and the force is applied at this direction and here, so that the wheel is rotating in anti-clockwise direction. That means this is the direction of rotation. In this way it is rotating. Draw a diagram to show the application of forces and calculate the moment of the forces applied. So here, since we have to draw the diagram by ourselves, so this is the diagram which we have drawn, and to rotate the wheel in anti-clockwise direction we have to apply the force in this direction, so that they will be rotating anti-clockwise, and 5 Newton is the force applied. We have to find out the moment of force also. So these are the two equal and opposite forces not acting along the same line. So we can find the moment of couple directly. So either force into perpendicular distance between them. So either force means it's 5 Newton into 0.5 meter, the perpendicular distance between them. So it's 2.5 Newton meter. Now question number 8. A uniform meter rule. A uniform meter rule means a ruler is there, and meter rule means its length is 1 meter. So we can write it as 100 centimeter. So this is the 0 centimeter mark and this is the 100 centimeter mark. Is pivoted at its midpoint. So its middle point, that means pivot point means this point is fixed. It is free to rotate about the point O. That is its midpoint. So since O is its midpoint, so here we can write the side here, this side will be 50 centimeter and another side will also be 50 centimeter. A weight of 50 GF is suspended at one end of it. So we have to suspend 50 GF. This is the weight which is acting downwards. The arrow must be there. So 50 GF weight is suspending from one end. Where should be a weight of 100 GF be suspended to keep the rule horizontal? So here, when we will be hanging the 50 GF weight from one end, and if we have hanged it in this end, so this will be rotating anti-clockwise. So to balance it, we have to hang the another weight which is 100 GF, and that has to be in the just opposite to this side. So here 100 GF weight will be here in this side somewhere. Now according to principle of moment, the sum of anti-clockwise moment equals to sum of clockwise moment. So here the only anti-clockwise moment will be equals to clockwise moment. So it's 50 GF in its formula. We know moment's formula, force into distance, perpendicular distance. So here 50 GF. 50 GF is the force and the distance from here is 50 centimeter. So 50 GF into 50 centimeter equals to 100 GF we have to suspend, we have suspended, into the distance we have to find here. So D into 100 GF. So now D will be, if we try to cancel it, or D is equals to this 50 into 50 by 100. So if it is cancelled, so 50 2s are 100 and 225 times 100. So it will become D is equals to 25 centimeter. So it should be kept at a distance of 25 centimeter from the other end. That means here at 25 centimeter mark, the 100 GF has to be suspended. Now the question number 9. A uniform meter rule balances horizontally on a knife edge placed at 58 centimeter mark. So again a uniform meter rule is here. So if this is 0, so this is 100 centimeter here. And it is balanced on 58 centimeter mark when a weight of 20 GF is suspended from one end. So always we have to remember that the whole weight of the meter rule will be acting at its midpoint. That means at 50 centimeter marks the weight W will be acting. So that means we cannot suspend the weight beside this. So that is why this 58 centimeter mark, though the whole weight will be acting on the 50 centimeter mark, but since 30 GF 20 GF is suspended on one end and this is balanced at 58 centimeter mark. So this diagram is very important and we have to understand how to draw the diagram. So the uniform meter rule balances horizontally on a knife edge placed at 58 centimeter mark. That means it is balanced over here, 58 centimeter mark, when a weight of 20 GF is suspended from one end. So this 20 GF is suspended from one end, then only it is balanced on 58 centimeter mark. Draw a diagram of the arrangement. So this is the diagram of the arrangement. Here this side, the weight, it will be in anti-clockwise direction. This will be in clockwise direction and this will be in anti-clockwise direction. And the whole weight of the meter will be acting from 50 centimeter mark. Now according to principle of moment, we know anti-clockwise moment equals to clockwise moment, because we have to find out the weight of the rule here. So if the weight of the rule is W here, so anti-clockwise moment here is force into perpendicular distance. So it's W weight here, and perpendicular distance is here from 58 to 50. It's 8 centimeter. So W into 8 centimeter equals to 20 GF into this distance will be 42 centimeter. 100 minus 58. Now if we cancel it, so it's 4 2s are 8 and this is 4 5s are 20. Now 2 will be also cancelled here. So 221 times. So W will be equals to 100. 5 into 21, that is 105 GF. So weight of the meter rule will be 105 GF. Now we'll do the question number 10. In question number 10, the diagram given below shows a uniform bar suspended at the middle point O. So the diagram is already there. This is the midpoint. From this side 10, 20, 30, 40, 50 centimeter, and from another side also 10, 20, 30, 40, 50. A weight of 40 GF is placed at a distance of 40 centimeter to the left of the point O. So here at 40 centimeter mark, 40 GF weight is suspended. How can you balance the bar with a weight of 80 GF? So since 40 GF weight is there and this is pivoted at the point O, so this will give the anti-clockwise moment. Now to balance it with 80 GF weight, we have to place it somewhere here in just the opposite side. So at what distance we have to place, that we'll find now. So according to principle of moment, we know anti-clockwise moment equals to clockwise moment. So now W1 into D1, that is weight into the perpendicular distance from the point O, equals to W2 into D2. So W1 is given 40 GF into 40 centimeter. The distance is here 10, 20, 30, 40 centimeter. W2 also given 80 GF into D2. So if we cancel it, so 40 to 80 here and 2 20. So D2 here 2 centimeter will be there because GF will also be same unit. So D2 will be equals to 20 centimeter. That means here At 20 centimeter mark we have to place the ATGF bar. ATGF weight we have, that means here by placing the weight of ATGF at a distance 20 centimeter to the right side of the point O. So here, over here, the ATGF will be suspended, so to balance. Question number 11 is saying, figure shows a uniform meter rule placed on a fulcrum at its midpoint O. So this is the uniform meter rule. The diagram is already there. So its length will be 100 centimeter and its fulcrum as its midpoint. So this is the 50 centimeter mark. So this is the pivoted point. And having a weight of 40 GF at the 10 centimeter mark. So 40 GF is there at 10 centimeter mark and a weight of 20 GF at the 90 centimeter mark. So this 20 GF weight is there at 90 centimeter mark. The first part of the question is the meter rule in equilibrium? So to find out are they in equilibrium or not, we have to find out the anti-clockwise moment and the clockwise moment. So anti-clockwise moment, you know the formula, it's force into perpendicular distance or the weight into the perpendicular distance. So here the weight is 40 GF and the perpendicular distance is 40 centimeter here. So 40 GF into 40 centimeter, so it is 1600 GF centimeter. Similarly, clockwise moment, it's 20 GF into the distance here also 10, 20, 30, 40, so 40 centimeter, so 800 GF centimeter. Since anti-clockwise moment is not equals to clockwise moment, therefore meter rule is not in equilibrium. So the first part was that. The additional part is, if not, how will the meter rule turn? So here we found the anti-clockwise moment is not equals to clockwise moment. So meter rule is not in equilibrium, but in which direction it will turn? So since anti-clockwise moment is more than the clockwise moment, so the rule will turn anti-clockwise. Second part of it, how can the rule be brought in equilibrium? By using an additional weight of 40 GF. So additional weight that we have to add, that is 40 GF. So this 40 GF weight we have to add where the moment is less. That means in the right side of the 50 centimeter mark. Because so that it can produce the clockwise moment. Now by the principle of moment we know the anti-clockwise moment equals to clockwise moment. So anti-clockwise moment is 1600 GF centimeter and clockwise moment equals to 800 GF centimeter is already there, plus 40 GF additional weight into D. At some distance we have to find out, because moments formula, always remember, it's force into distance. So if we simplify the equation, it will be 1600 minus 800 is equals to 40 into D. So 800 will be equals to 40 into D. So if we cancel zeros also here, and then 4 20s are 100, 4 20s are 80. So D will be equals to 20 centimeter. So what will the answer here? It's compulsory to write the answer. Hence, by placing the additional weight of 40 GF at 70 centimeter mark. Since here 20 centimeter, 20 centimeter distance we have to keep. So we have to keep this additional weight of 40 GF at the distance of 20 centimeter from the fulcrum. That means at 70 centimeter.